So function operations is what we're going to look at first. It literally is a review of Algebra 1, and we did go through this again in Algebra 2. The second page of this, which is composite functions, we've also gone through this in Algebra 2. So I'm going to go through both of these pages. It's designed to be a review, but I'm going to make sure that you guys have a good understanding of it before we finish up. So I'm going to look at this whole first page. The whole back side of the page I'm not going to get to. So again, you have more extra practice. So we're going to go through pretty much all of the questions here. So for example 1, it says for you to combine these. So you're adding both of these polynomials. When you're adding two polynomials, do you need to distribute anything like this? No. If there was a coefficient in front of either of these parentheses, then yes, you would need to distribute. But since there isn't, I'm going to rewrite this as 3x cubed plus 2x squared minus 10 plus 5x squared minus 1. You literally just drop the parentheses and then combine your like terms. So with the x cubed, I just have 1. I have 2x squareds, like the x squared variable. I have a 2x squared and a 5x squared, so there's 2x squared variables. So 2 plus 5 will give me 7x squared. Remember, you do not combine the exponents here, you're just adding. And then negative 10 minus 1, they're the same sign, but different numbers. So when they're the same sign, you subtract or add the numbers and keep the negative sign. The last thing you want to double check is to see if there's anything you can combine further. There's nothing else you can combine. That's your answer. So for example 2, can I just drop the parentheses here? You have to distribute. We're going to have 7x cubed plus 4x squared minus 2. The second part, we do need to change every single sign. So negative x cubed plus 2x squared all the way down to positive 4. Keep track of my signs for me because I think I changed the signs and sometimes I don't. So just make sure my numbers look like yours. Okay, everything's been distributed. Everything's been rewritten. So I'm going to combine my like terms. So I'm going to combine the x cubes. It's going to be 6x cubed, x squared. 4 plus 2 will give me 6x squared. I do have an x over here, so I'm going to actually rewrite this x next because I'm trying to write this in descending order or standard form. Descending order and standard form means you have the highest exponent with your variable, and it trickles down all the way to your constant. So I'm going to have minus x, and then the last thing I'll have is negative 2 plus 4. Negative 2 plus 4, you subtract the numbers and keep the bigger sign, so we'll have positive 2. This will be your answer. On tests and quizzes, please write these in descending order. So you start with the highest exponent and you work your way down to your constant. For number 3, this one is asking you to multiply this out. So I'm not going to necessarily go through this completely with multiplying, but make sure you just distribute everything for the first one. So you're just FOILing this out. I will, however, solve number 4. So for number 4, this has 2a plus 5. Do I just distribute the 3 or do I need to rewrite something? You guys said rewrite it 2 more times. That means I need to multiply the first 2 parentheses first using FOIL, and then the last parentheses, I'm going to have to multiply whatever the final answer is. So first I'm going to multiply these 2 parentheses, and you should remember how to do this. So 2 times 2 is 4a squared. 2 times 5 is 10a plus 10a plus 25. Okay, let me combine my like terms here. So it's just the 2 10s. And once you combine your like terms, you're just going to bring down the other 2a because that, or 2a plus 5, because you're going to have to multiply this binomial with all 3 of these terms. The way I'm going to do that is literally just distribute one number at a time. So 4 times 2, so 4a times 2a is 8a cubed. 4a times 5 is positive 20a squared. Be careful with your numbers and your signs. Next, I'm going to do 20 times 2, so that's going to give me 40a squared. Again, be careful with your signs and your numbers. 20 times 5 is positive 100a. Check my math, guys. Make sure it looks good. 25 times 2 is 50A. And then 25 times 5 is 125. All you have to do from here is combine your like terms. So the 8A cubed, I can just rewrite. The 2A squareds, so the 20A squared and the 40A squared, I can add those. The A terms, I can combine those. And the 125 just stays as a 125. You saw all of this back in Algebra 2, and Algebra 1. So I don't want to spend too much time repeating the same thing you already know. All right, I'm going to do, like I said, examples 1, 2, and 3, this whole front page. And then afterwards, we'll move on to the next page. So for an example 1, and if you know what you're doing, guys, move ahead. In example 1, this one is asking me to substitute the given expression in for the function of x, where you have x squared minus 2x. I'm going to look at these 3 questions that I have a check mark. Okay, so I know I have this function, and I want to replace for each of the expression or each of the parentheses that I have. Whenever you have a number in the parentheses, you're going to substitute it in for both of these x's, both of them. When you substitute in especially just a number, you're going to get an answer that's just a number as well. So you're going to have x squared minus 2x. And in place of both of those x's, I'm going to substitute in that -4. -4 squared is not 8, it's 16. And 2 times 4 is 8. So that's why I'm saying whenever you plug in just a number, guys, expect to get just a number answer. If you have a number and variable, then you're not just going to get just a number. 16 plus 8 is going to give me 24. So that's my answer. This smiley face, guys, it's not meant to be confusing at all. It just means if you were to substitute this in, you would have 2 smiley faces for x. That's all. For letter C, I'm going to replace the x's. So parentheses, that's x squared minus 2 times x. In both of those parentheses, I'm going to put a y. Do I really need to simplify anything from here? No, I mean, I might just clean it up and clean up the parentheses, but that's it. That's my answer. For this last one, though, I am going to have to do some work. So for letter D, I have x plus 3, and I have 2 spaces that I need to substitute this in. So we're going to have x squared minus 2 times x. I always plug these or make a space first before I plug things in. You don't have to do this, but this is how I make it easy. I'm going to add x plus 3 here and an x plus 3 there. All right, I know I'm going to have to FOIL this out, and I know I'm running out of space. So I'm going to multiply the x plus 3 squared over here to the side, and then I'll write out the rest. Okay, so let me FOIL this. I'm going to get x squared plus 3x. Can I combine anything? X squared plus. Wait, I can combine all? Oh, the 3x. Okay. So I can make this x squared plus 6x plus 9. If I'm moving too fast, guys, stop me. Please slow me down. So this in parentheses, or this trinomial, I'm going to put in parentheses. X squared plus 6x plus 9 minus, I can actually distribute that 2 because this -2, I'm just going to multiply by x and 3. So I'm going to make this -2x minus 6. I rewrote this in parentheses because if there was a coefficient in front of this x squared, like a 4, you would have to distribute that 4 after you FOILed it. But since there's no number directly in front of this parentheses, I really don't need this parentheses. I'm going to remove the parentheses because I ran out of space to rewrite it. And we're just going to simplify. So I'm going to rewrite this as I'm going to have x squared. The 6 and the 2 I can combine. So we'll make this plus 4x. And then positive 9 minus 6 is positive 3. All right, so let me write it again out here. X squared plus 4x plus 3. All right, For examples 2 and 3, I'm really just going through those to show you how I want them rewritten at times. I might put these expressions on your tests and quizzes, but in the form that I'm writing in green. So you guys are going to be able to compute these on your own, but I want to show you what it will also look like. So if I'm adding two functions, I might write it as f plus g of x, like this. When you see it written in this form, I'm just rewriting f of x plus g of x. So that's all I'm having you do. For f of x and g of x like this, you're just multiplying. So if I was to have you write it in a different form, I can have it as f times g of x. Notice that this is different from a composition because you know we're about to talk about compositions. This is a closed little dot. It's going to be little, really small. It's just going to be a little dot. That's going to be for multiplication. For subtraction, you're going to see p minus v of s. And then for division, you're going to see v divided by p of s. So in green, you're still doing the stuff that's in black on the left-hand side of each of these. You're still doing that computation. All I wanted to show you is how you can also see them written. So if you see them written like this, don't get confused. All right, I'm giving you guys about 3 minutes. Try the 4 questions at the bottom, every single one of them. For the first one, add. Second one, multiply, subtract, and then divide. So I'm giving you about 3 minutes. Try to do each. I think the first 2 are fine. Are y'all okay with the first 2? Okay, good. For the bottom 2, I heard a really good question earlier about for part A down here, if you have to FOIL this. You guys tell me, do you need to FOIL or can I just cancel both of the S plus 3s? You have to FOIL. you're kind of following PEMDAS in the sense that you have to multiply before you can subtract. So make sure, and I had the exact same question last class period. When you're trying to combine these, do not just cancel out the s plus 3's. Multiplication, do it first because it's stuck together already, then subtract the s plus 3. So you should have FOILed this part out first. Notice that I put a bracket around it because I want you to do whatever's here first. So if I was to FOIL this out, I'll get s squared plus 3s minus 4s minus 12. And then this one here, I'm just going to distribute the negative. So we'll have negative s minus 3. I mean, even if you waited and combined the like terms here and then distributed second, it's okay. But especially since I know I'm going to have to combine like terms, I might as well do it all together. So I'm going to have s squared. 3 minus 4 is negative 1. Negative 1 minus s, which is like another negative 1, is just negative 2s. And then the last thing will be negative 12 minus 3, which is negative 15. And notice that I'm writing these all in descending order. I'm starting with the highest exponent and I'm working my way down. For B, am I done? This one? What do I have to do? Oh, cancel out the s plus 3's. We did that back in Algebra 2 towards the end of the school year. So when you're dealing with especially fractions, if you have two binomials you can cancel, you can definitely cancel. And if you're one of those people who FOILed this out first, you're fine. But remember, if you're going to try to cancel something, which if you have a fraction like this, you might be able to, you're going to have to refactor it. So I try to leave things, especially if I'm given to them or if they're given to me in factored form, I leave them in factored form to see maybe if something might happen like this where I can cancel. So we're going to have 1 over s minus 4 for that answer. First page, are there any questions? I know I'm moving at like a kind of quick pace, but if y'all have questions, I don't mind answering them. The back side of this page is up to you if you do it. It's extra practice. Let's look at composite functions. I'm going to do a couple questions on the front side, and then we're going to do the application problem on the back side. Let's see what y'all remember how to do. So with function compositions, a lot of these are already kind of written in their nicer form. Towards the bottom of the page, these are the normal ways that you're going to see composite functions given with that big little bubble. Notice that this big bubble is not the same as this little dot that I have before. So this little dot represents multiplication. This bubble, which is kind of like an open circle, that represents composition. So I want you to keep in mind that if you have, for instance, f composed with g of x, you're really just doing f of g of x. So f of g of x. It's not negative. So I just want you to kind of remember from Algebra 2, because you saw this a lot in Algebra 2. These two are the exact same. So for instance, let's look at example 1. The first question is already in its combined form, so it's already done the composite. It's already been rewritten. I'm going to substitute in my values and try to solve. Since I have a number, I should get a number for my answer. So we're going to have f of your g function is 1 over x. So I can put this with the bracket or a set of parentheses. It doesn't matter. G of 4 is 1 over x. Instead of putting an x down here, I'm going to substitute that 4. Okay, well, I want to see if anything in this parentheses is going to simplify. Well, I mean, I really just have 1 over 4. The most I can actually do is just rewrite that 4 without the parentheses, but that's the most I can do. Okay, well, I can't simplify it any further. Now I need to do f of 1/4. So using the f function, I'm going to rewrite 8 times x plus 1. Instead of substituting an x, I'm now going to use 1 over 4. So I'm going to make this 1 over 4. What's 1/4 of 8? 2. And 2 plus 1 is 3. So for my answer, when I'm finding f of g of 4, the answer is 3. Depending on who your Algebra 2 teacher was, you can do this in a different way. There's plenty of ways to do these problems. I just like to work from the inside out to get my answer. If you have a different way of doing it, you're perfectly fine. All right, I'm going to look at one other question, and then I'm going to give you guys 2 to try, and then we'll see what happens. Let's look at this one, 2. Okay, so for example 2, it's s of t of x. Okay, so for s of t of x, I'm going to take the t function, so I'm going to work from the inside out. T of x is x plus 6. That's t of x function. Okay, I don't need to plug in a number, and I can't simplify anything in here, so I can't do anything. Let's go ahead and take the s function and plug it into the s of x function. So we're going to have x squared. Well, I have to replace the x with the x plus 6. And then just like we saw on the last page, we're going to have to FOIL this. So we'll have x times x is x squared. X times 6 is 6x. 6 times x again is 6x plus 36. All I need to do from here is combine my like terms. So my answer at the top of the page, I'm going to rewrite it up here because I ran out of space, is going to be x squared plus 12x plus 36. Like this? Only reason why I'm putting that is because on your tests and quizzes, I'm going to rewrite this and have a blank behind it. So I just want you to get in the habit of seeing it. On tests and quizzes though, or on like your homework, on your homework, you're just going to need to put this part. You don't need to put the whole notation. All right, you guys, because I know hoping y'all remember this. I want y'all to look at number 4 and number 7. Yes, I know there's fractions, but you guys will be fine. They're numbers 4 and 7. Why do I feel like y'all are getting scared of these fractions? Because I'm speaking facts. If you know what you're doing, you can keep going. I'm actually going to let's do 7 before 4 because 7 I think is easier since it has a number. So for question 7, it has that composition value or composition notation. So I'm going to put r of t of -8. And you can put a bracket around t like it's been doing for the other questions, but you don't have to. It's just grouping it together. So what you're going to do first is you're going to group the t of function in the parentheses first. So this t function is -1/2 x. So there's a couple ways you can rewrite this. We can literally just put -1/2 and then put x next to it. So you're really just taking half of -8. What's half of -8? 4. What kind of 4? Positive 4. Now you're going to take the numerator. And the numerator, I don't know why I put f, and y'all didn't stop me. This is a r. Oh, R. So looking at the R function now, so for R of 4, we're going to take this this fraction at the top, and we're going to substitute it in. So we have 7 over 2x minus 1. That x is supposed to be a 4 because that's the value that we just solved for. So we're going to make this 7 over 8 minus 1, and 8 minus 1 is just 7. What's 7 divided by 7? That's it. It just has a little fraction. For number 4, though, that's a little more fun. So for number 4 at the top of the page, let's look at that one. Oh, and let me actually write it in my function composition form. R composed with t of -8 is going to equal 1. Just 1. And then for number 4, this one has an x in it. We'll be fine. Notice that the 5 and x are both in the denominator. So you guys, I saw some of you guys like writing it with the little slash mark. Y'all know how to write a fraction. You should. Y'all are all in pre-cal. So we're going to make this q of x is this fraction here. So this is -3 over 5x. That's your fraction. Okay, in that fraction, I can't simplify anything. So I'm going to take what I have, and I'm going to now substitute it in for the p function. So for p, we have -5x all over 3. Remember, I'm putting a parentheses here because I'm no longer substituting x. I now need to substitute this fraction, which is -3 over 5x. Just focus in the numerator. So before I move on, have I lost anybody how I plugged this in? Just focusing in the numerator. What can I simplify? The -5 and the +5. -5 divided by 5 is just -1, not positive, -1. So I'm going to multiply -1 times -3, which is just +3, over the denominator here still has x. And we're going to divide all of that by 3. What do I do from here? What were you saying? I can't just cancel them. I have to do something first. Well, I have to, but how? Multiply by the reciprocal. We're going to keep the numerator the same, change the division into multiplication, and then flip this fraction. Right now, this denominator has 3 over 1. We're going to flip it to make it 1 over 3. You're right with needing to cancel out the 3's. You're right with that. But the issue is, I don't want you to just cancel out the 3's and tell me that x in the numerator is my answer, because that's not true. When you simplify it correctly, you should get these 3's cancel again, and you'll have 1 over x. Please don't make that mistake. So this is the answer that I'm looking for. Take the time to make sure you understand how you're simplifying these. All right, let's look on the back page. All right, so for all of this, it looks like a lot, but the good thing is we have 2 tables that are cut in the middle, so it's really just 2 small paragraphs. Okay, so this is an application, and this might be a type of question I give you on a test or quiz and ask you to actually find your answer. So for the first part, suppose a flu virus is spreading in the community. The following table shows the people infected N who have the virus D days after the initial outbreak. The number of people who have the virus is a function of the number of days, where you have N equals F of D. And I'm going to make that kind of note here. I just want you to be able to quickly identify what function that is. There is only one pharmacy in the community. As the number of people who have the virus increases, the number of boxes of cough drops sold also increases. The number of boxes of cough drops sold on a given day is a function of the number of people who have the virus, and that's going to be represented as B of G of N, or B equals G of N. The first question says we need to find G of F of 1 and state the meaning of the value in context of this flu epidemic. Okay, so for this first question, and the last couple pages, we've been having formulas. We've had nothing but equations. Now I need to look at a table. The table for me is actually a lot easier because all you're doing is you're just looking to see where these values are and what numbers correspond with them. So if we're going to work from the inside out, I'm going to actually show my work down here for g of f of 1. F of 1 is the first thing we're going to find. Where's the f table? At the top. So what's the value at f of 1? When n, or your values, d is 1, your n value is going to be 4. So down here, I'm going to put g of 4. I'm using this space as my final answer. That's why I rewrote it. Now I need to find g of 4. Okay, so looking at the context of these tables, we've already used the first one, so let's use the second one. What's g of 4 going to be? So down here, I'm going to have 14. So my answer that I'm looking for is 14. Now I need to think about what that means, because I technically looked at two different tables. Well, if I think back to the table at the top, this one was saying this is the number of people who have the virus after D days. And the second table is the number of boxes of cough drops that are sold on a given day to the number of people who are infected with the virus. So if I was to write this out as far as a meaning is concerned, the function is a representation of the number of people infected after the initial outbreak. These are the number of people who are infected after the initial outbreak, who, because if you think of the second table, these are the people who also bought boxes of cough drops. Who bought boxes of cough drops. That's what we're looking at. When you're trying to see what this represents, it's really a combination of both tables. So it's about the number of people who are infected after a certain number of days from the initial outbreak, and it also relates to the number of people who also bought those cough drops. So for part B, we're now going to fill in the chart. So this chart is representative of this function, B equals G of F of D. So B equals G of F of D. So in this table, I want you guys to try to fill it in. I'll give you a hint, and if you want to write work for this, you definitely can. For part B, first I'm going to find, okay, 0. We're going to plug in D is 0, so we're going to plug that in. G of F of 0. Well, if I use from the inside out, what's F of 0?
2.
What's G of 2? 5. You're using the second table. So start with 0, which is 2. That's how I got this one. Now I'm going to do G of 2, which is 5. 2 is here, 5 is here. This is my G table. So the answer I have is 5. Fill in the rest of this table. Priya. Hello. When the number of days is 1, what are the number of cough drops we're going to put in this bottom part? What about when days are 4? It's okay. You haven't gotten there yet? Okay, so let's look. So we know that we're going to have to substitute this 4 in for F. So let's find F of 4 first. Looking at this table, what's F of 4? Okay, so keeping that in mind, we're now going to have to find G of 14. Looking at this table, what's G of 14 going to be? 22. Let's do one more and then I'll leave you alone. for G or for G of F of 8. So look for F of 8 first. You got your number? All right, now find G of that number. There you go. Layla, do you have the rest of my table for me? Okay, well, give me what you got. What's 12? And then what about 16? Okay, you're good. 58. All right, that's it. That's all you're doing. So if I ask you to do something like this on a test or quiz, you shouldn't have too many issues with it. I'm purposely going to leave part C for you guys to do on your own. This is just extra practice because I want you to have some kind of extra practice where you not only compute the actual value, but you also interpret the meaning in the context of this problem. So are there any questions on what we just did? All right, perfect.